The strange thing about the Headphone Nebula is not its uncanny resemblance to audio gear. It's that this shape might be evidence of a secret companion, a star that died alongside the one we can see. We look at planetary nebulae as beautiful endings, but the Headphone Nebula tells a different story. Its distinctive form suggests a hidden partner. Based on NASA's astronomy picture of the day and astrophysical research, this video explores how a dying star's last gasp can reveal what it orbited. The lesson is that in space, symmetry often hides a second actor. In the constellation Lynx, about 1,600 light-years away, a faint glow drifts across the sky. It's called PK 164 plus 31.1, or the Headphone Nebula, and it looks exactly like a pair of old-fashioned headphones. Two rounded lobes connect by a bright arc, red hydrogen gas on the outside, blue-green oxygen inside. It's a planetary nebula, the remains of a star that lived and died like our sun will one day. But why does it look like headphones? Any planetary nebula starts when a medium-sized star runs out of fuel. The core collapses into a white dwarf, while the outer layers puff away into space. Normally, that outflow is spherical, a gentle, expanding bubble. But the Headphone Nebula isn't spherical. It has two distinct bubbles, punctured by a stream of hydrogen that cuts through the oxygen-rich inner region. Something must have shaped it. That something is likely a companion star or a massive planet. When a dying star has a partner, their gravity stirs the outflow. Material is funneled into jets, disks, and lobes instead of expanding evenly. The Headphone Nebula's twin lobes are a classic sign of such interaction. The central white dwarf is not alone. It has a dance partner, even if we cannot see it directly. This hidden companion is not visible in any telescope. It may be a faint red dwarf, or a giant planet that survived the star's death. But its gravitational influence is written in the nebula's shape. Astronomers call these bipolar planetary nebulae, and they are surprisingly common. About 10 to 20% of all planetary nebulae show some asymmetry, hinting at unseen companions. The colors we see in the Headphone Nebula are not just for show. Red comes from hydrogen atoms excited by ultraviolet radiation from the white dwarf. Blue-green comes from oxygen atoms that have lost 2 electrons. These colors map the nebula's chemistry and temperature. Where hydrogen is red, the gas is denser and cooler. Where oxygen glows, the gas is hotter and more tenuous. The headphone shape has another secret. The two lobes are not equal. One is slightly larger than the other. This asymmetry tells us the companion is not in a perfect circular orbit. Perhaps it is in an elliptical path, pulling more on one side during close approach. Over thousands of years, that uneven pull twisted the outflow into the off-center headphones we see today. Planetary nebulae like this one only last about 10,000 years before they disperse into the interstellar medium. That is a blink in cosmic time. So catching one in this specific shape is like finding a snowflake before it melts. The Headphone Nebula is a snapshot of a dying star's final act, shaped by a relationship we can only infer. Our own sun will become a planetary nebula in about 5 billion years. It will not form headphones because the sun has no companion close enough to distort its outflow. It will puff away as a nearly perfect sphere, glowing green and red for a few thousand years, then disappear. The Headphone Nebula, by contrast, is a monument to something our sun lacks: a partner. Every oddly shaped nebula tells a story of interaction. The Ring Nebula, the Cat's Eye, the Hourglass, all bear the fingerprints of companions. The Headphone Nebula joins this list, its familiar shape a reminder that even in death, stars are not solitary. The universe is full of pairs, and their influence shapes everything from planetary systems to the very last light a star will ever shed. So the next time you see an image of a nebula that looks like something familiar, ask yourself, why? The answer is rarely coincidence. It is almost always physics, gravity, gas dynamics, and a second actor pulling strings we cannot see. The Headphone Nebula is not just a cosmic novelty. It is a clue, written in gas and starlight, that even the loneliest star may have a companion. The Headphone Nebula looks like a novelty, but its shape is a direct consequence of stellar physics. The defining lesson is that asymmetry in a nebula is a signpost for hidden companions. In astronomy, symmetry is the default. Gravity pulls evenly, gas expands spherically. When we see something lopsided or structured, something else must be acting. That something else is often the gravitational influence of a binary partner we cannot directly observe. This pattern extends beyond nebulae. Exoplanets are inferred from stellar wobbles, dark matter from galactic rotation. The universe speaks most clearly not through what we can see, but through what we cannot. When you encounter a beautifully weird object like the Headphone Nebula, you are looking at an invisible relationship made visible. It's a reminder that science is not just about observing the obvious. It's about reading the hidden forces through their subtle imprints. The headphones are a cosmic signature of a partnership, a love story written in glowing gas that will vanish in a cosmic blink. So what's your favorite oddly shaped nebula? Is it the ring, the crab, or maybe the headphone? Drop it in the comments. And if you want to see more cosmic mysteries explained, hit subscribe. The universe has a lot more headphones where this one came from.